Okay. Pagka
Welcome to my Ultimate Redux course. I'm Mosh, and I'm going to be your instructor over the next few hours. In this course, you will learn everything you need to know to build real, complex applications with Redux. We're not going to work on a dummy to-do app. We're going to work on a real bug tracking application with a Node backend. We'll go over functional programming principles, writing clean code, designing complex stores, middleware, calling APIs, testing, and integrating with React. I'm assuming in this course you know nothing about Redux and want to learn everything from scratch. I will explain every line of code I write so you learn and understand all the underlying principles. I promise you, by the end of this course, you will know and understand Redux inside out. Now, before we get started, I want to tell you that I have a coding school at codewithmosh.com. Be sure to JavaScript applications. Redux is a state management library for JavaScript applications. We can use it with React, Angular, Vue, or even vanilla JavaScript because Redux is just a state management library. It doesn't care what library we use to build user interfaces. But why do we need a state management library to start with? Well, if you have ever built an application with a complex UI, you have probably come across this situation where you need to keep different parts of the UI in sync. Let's say the user changes some data in one part of the UI, and other parts of the UI should be immediately updated to reflect the changes. In more complex scenarios, the data can also get updated as a result of network requests or background tasks. In these situations, data can flow from one part of the UI to another and change in unpredictable ways. We have to write a lot of code to keep everything in sync, and when something goes wrong, figuring out how the data changed and where it came from becomes really complex. You might even end up with an infinite loop that is hard to break. If you encountered such problems in your applications, that is a sign you need a state management library. Facebook encountered this problem in 2014 and came up with an architectural pattern due to its Redux. Instead of scattering application state in various parts of the UI, it's a problem of synchronizing the data across different parts of the UI. But Redux's architecture also makes it easy to understand how the data changes in our applications. If something goes wrong, we can see exactly how the data changed, why, when, and where it came from. So in a nutshell, Redux centralizes our application state and makes data flow transparent and predictable. Action. So this is a food delivery application I have built with React and Redux. On the left, we have food categories such as soups, salads, and so on. You can select a category and add items to our shopping cart. Note that as I'm adding these items, the number of items in the shopping cart gets updated immediately. So let's add a bunch of items. Let's also add an entree. Now let's go to our shopping cart. Once again, we can update the number of each item in the shopping cart. As I'm doing this, the total price for this item, for the cart, as well as the number of items in the shopping cart get updated in real time. So all the data in my application is in sync because we have a single store where we're storing our application state. Let me show you where it is. This is Redux DevTools, a powerful tool for debugging Redux applications. It's an extension to Chrome. So over here, you can see my entire application state tree in one place. So we have these entities. We have our shopping cart. We have our food categories and food items. This auth object over here represents the current user. So we have all the information about the current user and their authentication token. We also have this UI property, which includes some UI state. Now let me show you something powerful. On the left side, you can see all the actions that I have performed in this application. So we can see I've added a bunch of items to my shopping cart. Now, if I remove the first item, green lentil soup, you can see we have a new action here, item removed. If we select this action, we can see the data associated with this action. So over here, I tried to remove the product with ID 5. Now, let me show you something very cool. I'm going to put this on the left side so you can see clearly. Let's jump to one of the previous actions. The UI got updated immediately. So we can go back to any of these previous actions and restore the UI in that state. This is called time travel debugging. We can also save the entire application state in a single file and reload the application from it later. How many times have you got a call from your client or your boss telling you that a feature in your application is not working? In these situations, we have to ask them, how did this happen? Tell me the exact steps that you followed. Then we have to repeat all those steps to reproduce the bug. Now, every time we change our code, our application gets reloaded and we have to follow those steps over and over. This is very time consuming. With Redux, we don't have to do this anymore. There's actually a tool called LogRocket that gives you an always-on Redux DevTools in production for every one of your users. So if a user encounters a problem, you can reload the application in the same state as the user and see what was going on. It's very powerful. Another benefit of Redux is that it allows you to cache or preserve page state. Let me show you what I mean. So over here, note that when I refresh the page, you're going to see a loading indicator for 3 seconds, indicating a slow connection. So look, refresh. Here's our loader. Now the menu appears, okay? Now, if we navigate away from this page and then come back to it, the menu is already there. You don't have to re-download it from the server because our entire application state is available on the client inside a single JavaScript object. Also, I can select a filter here, let's say soups, and sort the menu by price. Once again, if we navigate away and then come back, our menu is in its previous state. So let's quickly recap. Redux makes state changes predictable and transparent. We can easily see what exactly is going on and how the application state changes in response to every action. The second benefit of Redux is that it centralizes our application state, so all the data our application needs is stored in a single place that is accessible by all parts of the UI. With Redux, we can also easily debug our applications. We can easily cache or preserve page state and implement undo or redo features. So if your application needs these features, you may want to consider Redux.
Page state EC debugging preserve list. Oh.
The great thing about Redux is that it works with any libraries for building UIs. You can use it with React, Angular, Ember, Vue, even vanilla JavaScript. Plus, we have a large and growing ecosystem of add-ons. So these are all the great things about Redux. But all these great things come at a cost. Redux introduces some indirection and complexity in your code. This is partly because Redux is based on functional programming principles, and a lot of developers are not familiar with these concepts. But don't worry, I'm going to teach you the basics of functional programming very soon. Another problem with Redux is that Redux code tends to be verbose. You have to write some boilerplate code to get things done. This is one of the main complaints about Redux. So in this course, first I'm going to show you the traditional way of writing Redux code, which has a lot of boilerplate, but later on, I will show you the modern way of building Redux applications. You're going to learn how to write clean and concise Redux code free of boilerplate. So with all that, is Redux for you or not? We'll talk about that next. Myth is kind of arrogant and opinionated about everything. So he says that he uses Redux in every project, and so should you. Well, I tend to disagree. For every project or app, you need to understand what problem you're trying to solve, what your constraints are, and what solution optimally solves the problem according to those constraints. There is no such a thing as one size fits all in software engineering. If you're on a tight budget, if you're building a small to medium-sized app with fairly simple UI and data flow, if the data doesn't change in your app, or if you simply fetch the data on every page load and render it statically on the page, Redux is probably not the right tool for you. It's just going to complicate things and slow you down without giving you much value. So don't use Redux or any other tools because they're popular or someone told you to. Always think about your needs and the kind of app you're building. Now, John argues that you should always use Redux right from the get-go because the state management problem will get messy sooner or later. So it's better to have the right foundation in the project. Well, that reminds me of the old proverb. If all you have is a hammer, everything looks like a nail. Developers like John are often used to a certain way of building apps. they solve every problem using the same solution. And honestly, I think that's just basic human nature. We don't want to constantly think and figure things out. We like to be on autopilot. But if you want to be a real software engineer, you need a different kind of attitude. You need to be an active problem solver. So the bottom line, Redux is great. It provides a number of benefits at the cost of extra complexity in your code base. You will see this as we go through this course. For every app, you need to think about all the pros and cons of Redux and see if it's really the right tool
No, no quiero.
for you or not. In fact, Dan Abramov, the creator of Redux, once said, "You might not need Redux." This is a great blog post to read in your spare time. So, at the end of the day, I encourage you to watch this course to the end because it helps you see what Redux is all about and whether it's the right tool for your next project or not. Also, keep in mind that almost 60% of React projects are built with Redux. So if you're a React developer, chances are the next job or project you get is based on Redux. So you need to know how Redux code works and how to maintain it. And that's what you're going to learn in this course. If you look below this video, you're going to find the starter project for this course. So simply open this folder with VS Code or your favorite code editor. Now, all you have to do is to open up a terminal window, install the dependencies, and start the project using npm. So npm install. All right, all of our dependencies are installed. So now let's start the project with npm start. Now open up your browser and head over to localhost port 9000. You should see the hello world message. Now let me give you a quick overview of what we have in this project. So take a look at package.json. Here we have 3 development dependencies and they're all related to Webpack. In case you are not familiar with Webpack, it's actually a module bundler for JavaScript. So we can split our JavaScript code into multiple files and have Webpack combine them into a bundle. We also have Webpack Development Server, which is a very lightweight development web server. Now, over here, you can see the configuration for Webpack. This is pretty standard, nothing fancy here. So we're telling Webpack that the entry point to our project is this file, index.js, that is located in the source folder. Now, Webpack is going to start from here. It's going to get all of our JavaScript files and then combine them into a file called app.js, which is going to reside in this folder, this, which is short for distributable. And here's the configuration for our development server. So we're telling Webpack to launch our application from this folder on port 9000. Pretty straightforward. Before we dive in, let me give you a quick overview of how I've structured this course so you can get the most out of it. Redux is based on functional programming principles. A lot of people find Redux confusing because they are not familiar with these functional programming concepts. So the next section is all about functional programming in JavaScript. We'll be talking about concepts such as higher order functions, composition, currying, immutability, and so on. The following section is all about the fundamentals of Redux. In this section, you will see all the building blocks of Redux in action. We'll be talking about reducers, actions, action creators, and so on. Now, Redux itself is a very simple library. So in the following section, I'm going to show you how to implement Redux. It will no longer be a mystery to you. I will show you various tools. One of the most common complaints about Redux is that it involves too much code, too much boilerplate. You have tons of techniques to write clean, concise. We'll talk about some patterns and techniques that you need to know for building real complex applications. Then we're going to talk about middleware. This is one of the areas that a lot of people find confusing. So I'm going to make it super simple for you. Next, we're going to talk about calling APIs. I've seen a lot of bad code when it comes to calling APIs, a lot of repetition. So in this section, I'm going to show you a very cool and caching. The following section is about testing. Again, I've seen a lot of bad practices when it comes to testing. A lot of people blindly write tests and feel proud, but you need to learn how to write good tests, not just tests. So in this section, I will show you the proper way to test Redux code. And finally, in the last section, we'll talk about integrating Redux into your React applications. I'm going to show you both the old and the new way of connecting your components to a Redux store. So there's a lot we're going to cover, and by the end of this course, you're going to master Redux. If you have tried Redux and were confused, that's probably because you didn't have a good background in functional programming. So in this section, we're going to cover the essential functional programming concepts. I highly encourage you to watch this section to the end because understanding these concepts is crucial to build Redux applications. So let's jump in and get started. Well, functional programming is one of the many programming paradigms or styles of programming. You have probably heard of object-oriented programming. That's another popular programming paradigm or style of programming. Each of these paradigms has certain rules about how you should structure your code to solve problems. Functional programming was invented in the 1950s, but it has become quite trendy over the past few years. In a nutshell, functional programming is about decomposing a problem into a bunch of small and reusable functions that take some input and return a result. They don't mutate or change data. With this structure, we can compose these functions to build more complex functions. Now, what are the benefits? Well, these small functions tend to be more concise, easier to debug, easier to test, and more scalable because we can run many function calls in parallel and take advantage of multiple cores of a CPU. So these are the reasons why functional programming has gained a lot of popularity over the past few years. Now, there are languages that are specifically designed for functional programming, such as Clojure and Haskell. JavaScript is a multi-paradigm programming language. It's not a pure functional language. So it has some caveats that you need to be aware of, but we can still apply functional programming principles in JavaScript. And that's what I'm going to show you throughout the rest of this section. All right, our first lesson here is going to be a JavaScript refresher about functions. Chances are you know what I'm going to show you in this lesson, so please be patient with me. I want to make sure you've got the fundamentals right before we move on to more complex topics. So in JavaScript, functions are first-class citizens, which means we can treat them just like any other variables. We can assign them to a variable, we can pass them as arguments, and return them from other functions. Let me show you. So in our starter project, I'm going to write all the code in this file, index.js. So let's declare a function called sayHello that returns a string. Hello world, as always. Now, let's declare a variable called fn. We can set this to a number or a boolean or a string, but we can also set it to a function, sayHello. Note that I'm not calling this function because if we call it, we get its return value, which is a string. We don't want to call the function. We simply want to pass a reference to it. So functions are first-class citizens in JavaScript. We can treat them like any other type of objects. Nothing special about them, okay? Now, fn is an alias for sayHello. So we can call it just like calling the sayHello function. The result is exactly the same. We'll get a string back, okay? Now we can also pass a function as an argument to another function. So let's declare another function called greet, which takes a function for generating a message. Now here we can do a console.log and pass the return value of this function. So our greet function takes a function as a parameter and calls it over here, okay? Now we can call greet and pass a reference to the sayHello function. Once again, I'm not calling this function. I'm simply passing a reference to it, okay? So in JavaScript, we can assign a function to a variable. We can pass it as an argument. argument, we can also return it from another function. So let's get rid of this code. In our sayHello function, instead of returning a string, we can return a function. In this case, an anonymous function, because this function does not have a name. Now, inside this function, we're going to return hello world. With this structure, if we call call say hello, we're going to get a function back. Okay, that is this anonymous function over here. Now we can call this function and get our message. Now you might be wondering, what is the purpose of this? Why do we want to return a function here instead of a regular string? Well, this is a very powerful technique and it has a lot of applications in the real world. You're going to see that soon. All I want you to understand now is that in JavaScript, functions are first-class citizens. We can treat them like any other variables. In the last lesson, you learned that in JavaScript and other functional programming languages, we can pass a function as an argument and return it. Now, in this example, these two functions, greet and say hello, these functions have a special name in functional programming. They're called higher order functions. So a higher order function is a function that takes a function as an argument or returns it, or both. So instead of working on strings, numbers, or booleans, it goes higher to operate on functions. This is the reason why we call them higher order functions. The chances are you have worked with these higher order functions before without being aware of it. Let me show you. So I'm going to declare an array of numbers, 1, 2, 3. Now we can call numbers.map. Map is an example of a higher order function because it takes a function as an argument. So here we can pass a function like this. Number goes to number times 2. So we take each number and multiply it by 2. Another example of a higher order function in JavaScript is the setTimeout function. So we can call setTimeout. Here we should pass a function as an argument. Let's say we want to do a console.log of hello after 1 second. So setTimeout is a higher order function because it takes a function as an argument. Earlier, I told you that the idea of functional programming is to write a bunch of small and reusable functions and then compose them to build more complex functions for solving real-world problems. Here's a real example. Let's say we have a variable called input and we set it to JavaScript. Now let's add some padding around this. Let's say we want to get the input, trim it, and then wrap it inside a div element. So we declare another variable. Here we add the opening element. Next, we add our trimmed input. And finally, the closing element. Not bad. It works. This is a non-functional style of code. Now let me show you how to solve this problem using functional programming techniques. So what are the 2 steps that we need to follow here? First, we need to trim the string, and then we need to wrap it inside a div element. So we can implement each step using a small reusable function. So I can declare a function called trim that takes a string and returns the trimmed string. Okay. Here I'm using const because I don't want to reassign this function. Okay. Now, similarly, we can create another function, wrap in div, that takes a string. It doesn't care if the string is trimmed or not. It only wraps the string inside a div element. So we add our div element. Now, in the middle, we want to render the string dynamically. So we add a $sign and wrap it with braces. And with this, we can render this dynamically. Functions, as you can tell, are very easy to test. All we have to do is to give them an input and then observe the result. Very simple. Now, what do we want to do here? We have this input, right? We want to trim it first. So we call the trim function and pass the input. The trim function is going to return the trim string. So we can pass that as an argument to our second function, wrap in div. There you go. So we get the result. And this is what we call function composition in functional programming. Now we could take this to the next level. We can also create another function for converting a string to lowercase. So to lowercase. Once again, this function takes a string and returns the string in lowercase. Now we can take the output of the trim function and pass it to lowercase. So this is another example of composition. Now we have a couple of tiny problems here. The first problem is that we have to read this expression from right to left. So we have an input, then we need to trim it, next we need to convert it to lowercase, and then wrap it in div. That's one problem. The other problem is all this parentheses here. As we work with more complex problems, we'll end up with so many parentheses. I'm going to show you how to solve these problems in the next lesson. In this lesson, I'm going to show you how to use Lodash to simplify the code we wrote in the last video. So in case you're not familiar with Lodash, it's basically a very popular utility library for JavaScript. It also has a package with a lot of functions for functional programming. I'm going to show you how to use them in this lesson. So back in our project, open up a terminal window and install Lodash. All right, beautiful. Now on the top, we're going to import two functions from Lodash. One of them is compose, the other is pipe. We're going to import them from Lodash/fp as in short for functional programming. So all these utility functions for functional programming are defined in this package. Now, now with these two functions, we can get rid of all this unnecessary parentheses over here. Let me show you. So first, I'm going to use the compose function. We call compose and give it three arguments: wrap in div, to lowercase, and trim. Once again, note that I'm not calling any of these functions. I'm simply passing a reference to them. So compose is another example of a higher order function because it takes a bunch of functions as arguments and returns a new function that is the composition of all these functions. So it's a higher order function. Now, we can get the return value, which is a function, and store it in a constant called
What is a higher order?
transform. Then we can call transform and give it the input. So with the compose function, we no longer need to do these nested function calls. Our code is cleaner. We don't have all these parentheses polluting the code. There's just one tiny problem here. That is the order of our operations. So once again, we have to read this code from right to left. To solve this problem, we can use the pipe function. So we call pipe and list our functions in the order we want to apply them. So first we're going to trim the input, then we're going to convert it to lowercase, and finally we're going to wrap it in a div. So we no longer need this ugly code with all these parentheses. Delete. Good. In this lesson, I'm going to show you a powerful functional programming technique called currying. Unlike what you might think, this has nothing to do with food. This is named after this guy, Haskell Curry. So back to the problem from the last video. Let's extend this program and create a function for wrapping a string inside a span element. So over here, we create a new function, wrap in span. And let me copy this code from here and then replace div with span. Pretty straightforward. Yet there is a problem in this code. We have a bit of duplication. These two expressions look very similar. The only difference they have is in the type of element. It would be nice if we could parameterize this function. So instead of wrap in span, let's call it wrap and give it two parameters, type and input string. Then instead of the span, we're going to render the type. Okay. Now let's get rid of wrap in div and instead use our new function, wrap. Finally, let's log the return value of the transform function on the console. Save the changes. So here's what we get. JavaScript, undefined. That doesn't make sense. Here's the reason. This pipe function essentially builds a pipeline. The output of each function ends up being the input of the next function. So what is the output of the two lowercase function? It's our input string in lowercase, right? So that gets passed to a wrap function. Now this function has two parameters, type and input string. So our input string in lowercase gets passed as the type argument, and the second argument becomes undefined. That is the reason why we get this result. Now, what if we call wrap and pass div as the type of element? Let's save the changes. Back in the console, we get this error, expected a function. Because every argument to the pipe function has to be a function. In this case, we're calling the wrap function and give it div as the type of element. So this is going to return a string. We cannot pass a string in the pipe function because we cannot build a pipeline with a bunch of functions and a string. It doesn't make sense. So here's the problem you're facing. We have a function with two parameters, but what we need in this pipeline is a function with a single parameter. And that's the problem that currying solves. Let me show you. So I've created a separate file called currying. Let's study currying in isolation, and then we'll come back to our main file. So let's say we have a function for adding two numbers, a and b. Here we return a and b. Currying is a technique that allows us to take a function that has n arguments and convert it to a function that has a single argument. So to apply currying here, we get rid of b as the second parameter. And instead of returning this expression, we're going to return a function that takes a parameter called b. And then inside this function, we're going to return a plus b. So when we call the add function, let's say add1, this is going to return a function. Let's call it add1. So every time we call this function and give it a value, it's going to add 1 to 8, okay? Now, in this case, we don't need to store this function in this constant. We can call add1. We know that this returns a function, so we can call that function and pass our second argument. So with currying, instead of separating our arguments with comma, we separate them using parentheses. But what matters here is that we have a function with a single parameter. Now we can also rewrite this function using an arrow function. So let's declare a function called add2. Now this function should take a parameter called a and return a new function. So a goes to. Now here we should return a function that takes a parameter called b. So b goes to and returns this expression. So once again, instead of separating our parameters using a comma, like a and b goes to a plus b, we are separating them using arrows. This is the result of currying a function. Now let's apply this technique in our main program. So the problem we have here is that the wrap function takes two parameters. We want to
Currying is the method. It takes multiple. Currying, yeah, currying is a process of transforming a function. Take multiple functions. Currying. Currying is a transforming a function which has multiple sequence. But it makes the functions more reusable.
Apply currying here, so we end up with a function with a single parameter. So to separate these parameters, instead of a comma, we're going to use an arrow. So we don't need parentheses because we have a single parameter. Type goes to, string goes to this expression. This is our curried function. Now, here's the interesting part. When we call wrap and pass div, we get a function instead of a string. So we can pass that function as another step in our pipeline. Let's save the changes. And here's the final result. So we wrapped JavaScript in a div element. With this new implementation, we can replace div with a span or any other elements. Save the changes. There you go. So we don't have to create so many functions for creating HTML elements. There you go. So we don't with a span or
Oh, it's output or it's written thing to the next.
or any other elements. Save the changes. There you go. So we don't have to create so many functions for creating HTML elements. Hey, Mosh here. Thank you for watching my Redux tutorial course that is the full complete. Another important concept in functional programming is pure functions. We say a function is pure if every time we call it and give it the same arguments, it always returns the same result. Let's look at a few examples. Look at this function. Do you think this function is pure or not? It's not, because every time we call it, this math.random method generates a new value. So the result of this function is going to change. In contrast, this function is pure, because every time we call it and give it 1, we always get 2. So in pure functions, we cannot use random values. We cannot use the current date time, because again, this will change. We cannot read or change global state like DOM elements, files, databases, and so on. Because if we rely on global state or change it, this can affect the result of our pure functions. Now you might say, but Mosh, how are we going to update our DOM elements or our database? Well, in practice, not everything has to be pure, at least when practicing functional programming with JavaScript. In Redux, we have special functions called reducers. We'll talk about them in the next section. When building Redux applications, we have to make sure that our reducers are pure. Other functions in our application can be impure. That's not the end of the world. Now, in pure functions,
Oh, reducers have to be.
we cannot mutate our parameters, because if we do, So again, the result of a pure function can change. Let's look at a few more examples. So this function takes the age of someone and compares it with minimum age. As you can see, minimum age is not defined here. So it's a global variable. Now, if you rely on this global variable to see if someone is eligible or not, the result of this function can change in the future. So if somewhere else we change the minimum age from 18 to 21, this function is going to return something different. To make this function pure, we have to pass minimum age as a parameter. So everything this function needs should be specified in its parameter list. Now, what are the benefits of pure functions? Well, the first benefit is that these functions are self-documenting because everything a function needs is clearly specified here. Now, this makes these functions easier to test because we don't have to set some global state prior to testing these functions. Also, because we don't use global state or change it, we can run these functions in parallel. And finally, another benefit of these functions is that they're cacheable. For example, if we call this function and give it two arguments like 1 and 2, and we know that this always returns 3, we can store the result in a cache and use it in the future. This is useful in functions that have intensive computations. So if we know for sure that they produce the same result or the same arguments, we can optimize them by reading the result from a cache. So these are the benefits of pure functions. We should know that this is easier to test because we don't have to set some global state prior to testing these functions. Also, because we don't use global state or change it, we can run these functions in parallel. And finally, another benefit of these functions is that they're cacheable. For example, if we call this function and give it two arguments like 1 and 2, and we know that this always returns 3, we can store the result in a cache and use it in the future. This is useful in functions that have intensive computations. So if we know for sure that they produce the same result or the same arguments, we can optimize them by reading the result from a cache. So these are the benefits of pure functions. In the last video, I told you that pure functions cannot change or mutate their arguments. So a concept that goes hand in hand with pure functions is immutability, which basically means once we create an object, we cannot change or mutate it. If we want to change that object, we have to take a copy first and then change that copy. For example, strings in JavaScript and in most programming languages are immutable. So if you have a string and then try to convert it to uppercase, we get a new string. The original string is not affected. In contrast, if you have an object, we can change or mutate that object directly. So in JavaScript, objects and arrays are not immutable. And that's why I told you that JavaScript is not a pure functional programming language. In pure functional languages, we cannot mutate data, period. But in JavaScript, we can mutate objects and arrays because JavaScript was not designed to be a functional language. It's a multi-paradigm language, but we can still apply functional programming principles when writing JavaScript code. Now, what about the const keyword? Well, this is a common misconception. When you use const, you're not creating an immutable object. So we can declare book as a constant and then change its title property. With const, we cannot reassign book to a different object. So const prevents reassignment, okay? Now, what are the benefits of immutability? Well, the first benefit is that it makes our applications more predictable. If we call a function and pass an object to it, we know that object is not going to get changed. So there are no surprises down the road. The second benefit of immutability, which is kind of specific to React and Redux kind of applications, is that it makes it faster to detect changes. So you know that React needs to know when the state is changed so it can trigger re-rendering. For example, let's say we have a book object stored in the memory location 100. Now, if we follow immutability, to change a property of this object, we have to create a new object. This object is going to be stored in a different location in memory, let's say 200. Now, React can quickly tell if an object is modified because it compares these objects by the references. It's like comparing 100 with 200. This is a very fast operation. In contrast, if we don't use immutability, React has to compare every property of an object to see if it's changed. So immutability makes change detection faster. And the third benefit of immutability is concurrency. If we know that a function does not mutate data, we know that we can safely run this function in parallel. it's not going to change something in memory that's going to mess up the state of the system as a whole. So, doesn't mean object mutation is bad and we should always favor immutability. Well, if you ask John Smith, he would say that's exactly right. But in my opinion, every approach, every technique has its own uses, pros, and cons. Anyone telling you that one technique is objectively good or bad in all situations is selling you something. So we talked about the benefits of immutability, but these benefits are not free of cost. There is a potential performance cost to immutability because every time we change an object, all the values should be copied to the new object. However, this would only be an issue if you're dealing with a large number of objects, let's say several thousand or hundreds of thousands of objects. If you're dealing with a few objects, that's not going to be an issue. Another problem with immutability is that copying objects can also cause memory overhead. But we have immutability libraries out there that reduce these overheads as much as possible. They use a technique called structural sharing. So if some values are common between two objects, they're not copied across, they're shared. We'll talk about these libraries soon. So the bottom line is, if you're building applications with Redux, you should not mutate data because that's a fundamental principle in Redux. Outside of Redux, you can do whatever you want.
Redux table storage. Redux date. Immutable. Immer. Oh,
A fundamental principle in Redux. Outside of Redux, you can do whatever you want. So, now that you understand what immutability is and why it's important, let's see how we can practice it in JavaScript. So let me show you how you can practice immutability when working with objects. So here we have a personal object with a name property. Now, if you want to update this object, we're not supposed to set the name property